Hey everyone, welcome back to my channel EduVibe. Today we'll start with the second half of the momentum and impulse, which is the iterations in two dimensions. So this topic is pretty much long. So we will cover this topic in few lessons. So our first topic for the iterations in two dimensions is the right angle iterations. We are just talking about the right angle iterations in two dimensions. So how the iterations can be occur in the if we have a right angle iterations, how they can be occur. So let's start with some things you have to know about this, that how can we deal with the two dimensions. So the two dimensional iterations, we will look at the momentum in both x and the y directions. So here when we introduce about the x and y components of the grade 12 physics. So you are doing the x and y vectors addition and physics in grade 11 physics. But in this we will use the momentum. So the conservation of momentum applies to each direction separately. When we use these, so x and y directions literally use the conservation of momentum. So we treat them independently in our analysis and join them back to the final stage. Let's say when we deal with those type of questions, so firstly we find the x component, then we find the y component, and then we combine them both to get the final result. So that's how we can work with this. We use the vectors in this because this is a more likely the vector addition type, but we use in the momentum aspects. Then in two-dimensional iterations where no external force act on a system, the momentum of the system in both an x and y directions is conserved, remains constant. So we know that there is a no external force act on the system because this is type of a iteration we will do. So an x and y direction is conserved and remains constant throughout we are doing. So let's move on to the example of this. If we like, there are more type of questions related to this, but this type of question we will discuss today is about the right angle iterations particularly. So the question says at the iteration in 112 Avenue and 82 Street, many people tended to ignore the red light there. On a typical Edmonton day, a Jaguar F-Type, mass of this 1725 kgs, is traveling north on 82 Street at 35.0 meter per second. Unfortunately, the driver goes through a red light and smash into the Dodge Ram 1500, which is about mass of 2385 kgs, that was traveling west on 112 Avenue at 20.0 meter per second. The two vehicles stick together after the collision. So we have to determine the velocity of the combined venture after the collision. So this type of question is you can there mention this is the hit and stick. As I told you that in the previous lessons that in two dimension we will again use the hit and rebound, hit and stick, and more we would use the explosions too. So this question is a hit and stick, and but there is like a things which we have to know that we have directions over there. We have a north direction, we have a west direction. So the north and west direction where we comes to the right angle directions. So they mentioned there is a north direction from where the one F type of car is traveling, and this is north. And from the west, so from the west, there is a Dodge Ram is going, and they both stick together after the collision. So they stick together as we know that there is a stick and hit and stick formula which we use in this. But in that case, that if they Y, so you all know that this is the like this type of cone. This is the north, this is the south, east and west. That east and west is those on the x-axis because we know that this is the x-axis, and that's north and south is the y-axis. In that case, the north we take positive, south we take negative, east is positive and the west is negative. But when we in the question we have like a two directions, like we have a north and west direction, we take both as positive. Which two directions we have, we both take as positive, and the rest of the east we take negative and south we take in that case negative in question if we have. But in journal we have these things we have to know, that if we have the certain directions, so we have to know that this direction has a this negative or positive sign. So we have a two masses, and both have like a different velocity and the different mass. So we have to cover, like this is the like a x component and y component, we have both components. So we measure first the x component, then the y component. Firstly we have to measure like this. So firstly we'll start with the x component. So x component is like we have a initial someone like p1s, which is momentum initially at the x component, plus we do p2s, which is our second second vehicle in the x direction if they have. So this is equal to, so that is, this is the hit density, so we have a combined momentum of this in the x direction like this. From they say that in the x component which direction we have, they like this type of this f type is going to the north, but the north is the y direction, so this will not be taken in this question. In the x component we didn't take this, so this is the y direction, so we talking about the x direction, but this is the y component, y direction, so we take this as a zero, we ignore this value. For second vehicle, we have Dodge Ram is on the west direction. So it's the west. So this is the west direction. So our west direction is the x direction. So we take it as in the x component. So we take this P2s, and P1 to s is the final one. We always take this. So now we are left with M2 V2s. We put the formula which is P and V of momentum. And for this one, P112, this is the combined mass, because this is a hit tense kick and we have a combined final mass like this in the x component. So what we have to find? We have to find this thing, this combined mass, from where we can calculate the velocity of the combined one. So that M2 is 2325 kgs. Our V2s is 20.0 meter per second. We get west as positive, so it is positive. This m1 plus m2 goes over there, so it's divide, and we only left with over this thing. So here we have 1725 kgs plus 2325 kgs. When we solve this, we get combined velocity in the x component about 11.481 meter per second. So we get the v1 to x final. Now we have to find the in the y component. So for the y component, the formula remains the same, but the x now converted into y. So it's p1y plus p2y is equal to p12y. So now our p1y is in the y north direction, which is the y direction, so it keeps, but this p2y goes out because this is in the s direction. So now m1 v1y is equal to combined masses of the combined velocity. So now that m1 is 1725 kgs, that v1y is 35.0 meter per second. Again, this is in the north direction with a north as positive, so this is, and the m1 plus m2 goes over there, so it divides. So this plus this. So what you get for this, we get about 14.907 meters. So we we calculate the x, in the x component we calculate the velocity, and in y component we calculate the velocity. So this is a combined velocity, but we want that in the combined form when the after the collision. So this is the thing which we have to calculate first. Then now we have to make the vector diagram for this. To make the vector diagram, we have to just follow these things, not the things which we have in question now. So let's move on to the vector diagram. So this now, so vector, most important part when we correctly follow this thing that the x1 and the y1, then from there we have to make. So here that our v2sf v2fs is in the x direction, so this is in positive. You have to remember the signs. This is in positive and this is also in positive, so both are in positive and the x direction is goes to west. So we take the v2 v1 2sf is in the, there's a dotted line which is our V12SF. And our V2YF is also in positive, and this is going to the Y direction, so it's a north. North is positive in that case. So this is your V12VF. And we have to find that vector. We have to find the V12F, not the X or Y. We have to find the combined one. And this from here, this is our right angle and this is our theta. From here we can tell this is a right handed direction because this meets the right angle. So now there's a two things after this we have to find. First is the magnitude of this thing, and then the theta, this one. So from the theta we find the direction, and from there we find the magnitude, which is a combined velocity of the venture after the collision. So let's find it out. So v12f magnitude, we have to find like the Pythagoras theorem. So v12x f square plus v12yf square. So we have to put these two values in the question. So put the non-rounded values to get the accurate results. We get about 18.8163 meter per second. Now we have to find the theta. Theta we have to find it by this. So tan theta, this is our base, this is the perpendicular, and this is the hypotenuse. So perpendicular upon base, which is v12yf and v12sf. So from here we have 14.907 meter per second and 11.481 meter per second. When you do this for this whole value, so you get theta about 52.397 degrees. So how can we follow the direction? So how can we make the direction for this? So that direction which is opposite to the theta angle, opposite to this angle, which is this direction. So this direction always goes first, then we put this direction. So in that case, we have a north of west. So just now you have to combine the all things, that v12f is equal to, we want 3 seconds, so 18.8 meter per second and 52.4 degree north of west. So this is the answer for the combined velocity after the collision. So that's how you can deal with this. There's a lot of words, so you get the 4 marks when we 4 out of 4 marks when you do all that things by like very like they this way. So you get the full marks in this. So that's a question we will deal, and in the next lessons, when we completed this, we will go on to doing the practice questions with the more this type of question. There's only one example, just like the introductory part, because in later on we will do the more complex one. So if you have any questions related to this, let me in the comment section. Learning made simple with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. In the next lesson, we will start doing to the another vector, which is a vector resolution, and then we move on to the next things. So see you in the next lesson. Till then, stay connected with EduVibe.